My name is Darina Sherban and I am from Team Ukraine, and I will present the solution on problem number 13, pickle night light. So the aim of the research was to investigate the effect and describe the mechanism of the appearance of the glow in a pickle when a current is connected to it. And for the study of this effect, we will demonstrate you a qualitative experiment and analyze the spectrum of this glow, after which we'll can formulation the mechanism of the appear on the glow. Also, we would need to get decide heat and electrical problem for the gate distribution of heat and current taken into account appearance of the gap near the electrode. And after that, we will consider dependence time before the breakdown and time of the glowing on different values of parameters of the system. And also we'll consider this effect in the chains of pickle. For the experiment of this effect, we use a voltage amplifier connected to the pickle and the oscilloscope for measure dependence of voltage and the current. And as we see in the demonstration, after the current is applied to the pickle, firstly, smoke appears near the electrode, after which the glow begins. But after some time, glow stops. So for the better understanding of this process, let's move to the analysis of the oscillogram. We can observe linear dependence of current on voltage before the breakdown, but with time, strong current increase observed when voltage becomes negative, which correspond with peak of breakdown. And after breakdown, current becomes low again. And for understanding of this process inside a pickle, we could open the pickle to see the area near the electrode. And as we can observe in the photo, after the experiment, an area of burns is visible near the electrode, and glow, we can conclusions that glow comes from part around the electrode. But what is determine the characteristics of glow? We decided to keep the pickle in solutions of different salts, and we can see that glow is determined by the salt vapors. And for the better analysis, we consider spectrograms of spectrum analysis. We can observe the peaks which coincide with the values of wavelengths for water, hydroxyl group, and sodium. If we zoom area into highest peak, this peak corresponds with duplet lines for sodium in a solution of sodium chloride. And now we can formulate the mechanism of effect. And after the current is applied, the temperature near the electrode rises, and when it reaches the boiling point, a gas gap appears. With sufficient voltage and thickness of this gap, an electron charges arises, and as the gap increases, the voltage becomes insufficient and the glow stops. For the gate distribution of heat and current, we need to solve the electrical problem firstly. And for investigated the flow of current through the pickle with gap, we write the Gauss law, Ohm's law, and continuity equation, taking into account boundary condition on the area on the surface of the pickle and on the electrode. But for the solution, we need to know value of electroconductance, and we can find these values from an additional experiment, and we see that the electroconduction increases with increasing salt concentration in the solution. And after determined these values, we can get a current distribution near the electrode in the pickle. If we know the distribution of current, we can solve the heat problem inside pickle. And we write the heat equation taking into account the Joule heat and the boundary condition on the electrode equal to 0. We get the temperature distribution without a gap in area around electrode. And this distribution we can see on this animation. But to get solution with considering gap, we need to consider gaps evaluation. So we assume that there is 3 ionization process is direct ionization of sodium atoms by electron impact, direct ionization of water molecules by electron impact, and we also taken into account pain ionization of unexcited sodium atoms due to their collision with water molecules excited to the first electronic label. Now we can write potential formulation of Gauss law taking into account continuity equation for the electrons, positive ions of sodium and water. Also, we write the Ohm's law with considering condition on Pickle border, but for the determine but for the solution this equals these equations, we need know first Townsend coefficient for the determined frequency of ionization, and dependencies of the first Townsend coefficient for ionization we obtained using the Boltzmann plus code, and we find cross section from the Alex cat side, and to find, but voltage is still undefined, and we need to find voltage on gap, and to find voltage on gaps border, we solve conductions problem inside and outside the gap, taking a boundary condition into account. Now we can get solution to the heat equation taking into account evaporation and the appear of a gap near the electrode. The solution to this equation is shown in the animation. Also, we get a solution for dependence thickness of the gap on time, but for highlighting an area of breakdown, we need to know the value of voltage, which we can determine from Paschen curve, what we can determine by Paschen curves. And we see that breakdown voltage for pure steam is quite high. However, it is seen that even a small addition of sodium to this solution can significantly reduce the minimum discharge voltage. Also, from this dependence, we can determine the necessary values of thickness for the start of glowing. Thus, we can highlight the area of beginning and end of glowing. See what is more time of glowing is defined by duration of breakdown stage. We also get the dependence of the voltage on time and see that the voltage drops comparable to time of glowing. Next, we turn to the study. Of the breakdown time and time of the glowing Okay, we depend these times before breakdown decreases on concentration. This is due to the appear of Joule heat, and at low concentration the current is insufficient to burn out the gap and break down. And okay, can move to the dependence dependence time of glowing, and we see that on the dependence we see with increasable voltage time of glowing increases too, because necessary thickness of gap stays bigger by Paschen curves. Now consider the effect in a chain of pickles. There are two possible glowing regions when only one pickle glows, or under special geometrical and experimental conditions, several pickles glow homogeneous. And the glow time in this case is determined by the voltage in a chain. And we can get dependence time of glowing on numbers of pickles in a chain for different numbers of glowing pickle. And also we get dependence time of glowing on voltage with different numbers of pickle. So we can conclude that we, considering all stages of Pickle's glow, analyzed spectrograms and oscillograms, gave a qualitative explanation and investigation the glow spectrum. Also, we solved problem of current flow and investigated heat problem and the condition of gap formation and start of glowing. Also, we find it current flow through a gas. and we get decided dependence time of before breakdown and of glowing on voltage, and the salt concentration is a solution. And also we investigated this effect in the chain of Pickle. Thank you for attention.
Okay, and we are going to talk about the problems review and about strong and weak points and advice and the conclusion and so on. And in this problem, we believe that the keyword is alternating current, multiple pickles, and the mechanism and time. And in this 4 points, I think the reporter has done a good job. And we are talking about the points. And first of all, the qualitative of the experiment, I can first see in the report they just use the some figures to show that the mechanism, and they also find out the negative parts of the voltage. I think that is really good, and they also analyze the current and the temperatures change, and they find out the temperature the change of temperature will influence the cavity, I can say, just the cavity. And finally, just they analyze the time of the glowing. And the strong points, I think they just do many kind of solutions, and they even shows a figure about just when the pickle began to glow and when it will die out. And then the temperature is considered, I think because the pickle was first it was cold and they become hot, and that's maybe a key point of the problems. And then they just analyze the concentrations of the solution of ionizations. And then I think there are some weak points of the reports. First of all, the experimental points is depart from theory. I want to see more connection of the experiments and the theory. And also, just like I said in the pole, your poles are not fixed. So, in my opinion, the pole position is can influence the diode time and even can make the diode just make the light just didn't die out. Because in my experiment, I just keep to push the pole together and make the pole just touch the pickle tightly, and then the temperature was just keep in a really high level, and the light was just glowing in a long time until just it can't just die out until the poles are getting together. I think you need to think about the pose position and when it's not fixed. And there's some advice. And in your multiple pickles experiment, I want to ask how many pickles will glow in a chain. Just that if you just put 5 pickles in a chain, and maybe just in our experiment, sometimes there will be 2 pickles, but most of the time there was only 1 pickle will glow in a chain. And I want to ask you if you just do some conclusion of this influence of this point. And the second point is that the influence of the position of the post. In the problems video, we can find that the post just vertically insert into the pickle, and in your experiment, you just put the pickles on the top of the pickle, and I think the electric position is not maybe.
Okay. Firstly, about how many pickle is glowing. As we can, as no.
Yeah, this is
On this dependence, we can see that is dependence time of glowing on number of pickle, but this point red, green and purple is the number of glowing pickle. So for example, if we observe chain of 3 pickle, we can see that only 1 or 2 or all pickle can glowing. Ponion? I understand.
I can ask that the point in your figure is not is in the distance of 1, 2, 1 and 1.5. Is that just you count it by the time of its glowing, or
Can you repeat a question?
oh, sorry, my web is not so good. And I want to ask, your point is just your point in the figure is not the integer, you know, it's just the 1 or 2. You just guess just 1.5 or something. I want to ask how you just count it and get the.
Okay. For the when we observe the chain of 5 or 6 pickle, as I said, we need to have a special geometric and experiment condition.
Let you speak yourself. You should speak yourself.
For the glowing of all pickles in the chain, we can have a special experiment condition, and we cannot to have this condition for the chain of 5, 6 pickle, and we can observe only the 2 or 3 pickle is glowing in this chain.
No, okay, I got it. And I want to discuss with you that in my theory about this problem, I just think there is some electric arc in the cavity between the pole and the pickle, and those arc just provide energy for the glowing. And what do you think about that?
We think that the temperature in the gap is 100 Celsius degrees.
I'm not asking about the temperature. I just that the mechanism about the glowing. You know, because I can say that you know, the pickle strikes just like a vapor lamp, and there may be some electric arc, and when we just doing the experiment, I can see the electric arc clearly. And I believe that is the key point of the glowing. And you didn't, when in your report, I didn't see that point, and I want to ask that.
Okay. We can see the glowing in this gap because near the electrode we can see the breakdown.
Okay, and maybe we need to change the problem question. And I just asked that when the pickle glowing, there's some steam that pump out from the pickle, and I think the steam may carry out some salts, or and it may influence the concentration of the ionization, and that may influence the dial time. And what do you think about that?
May the reporter steam answer?
Yeah, sure. We have general discussion.
Okay, yes, indeed, in this process, the steam comes out, and indeed it carries part of the gas which is inside the gap. In our theory, we investigated this process of the coming out of the air because we consider the pressure inside the gap to be nearly the same as the atmospheric pressure, and thus do not change. It is not a closed system. In our theory, we didn't think of this as a closed system. We indeed taken into account that the steam comes out.
Okay, I think that may be some explanation. And what about the fixed and or the move about the poles problem? I think the poles may change, may move and influence the diode.
Okay, yes, indeed, the motion of poles may change the distribution of currents. We investigated this in the current flowing problem, but in our experiment to reduce this effect, we fixed the poles and thus investigated the problem of the burning out of the gap in the same way as we investigated it in a theory. So we got the same conditions of the experiment, no problem.
Okay, I think if you just fix the pole, I think maybe your theory is okay, and I can say that it's good. And my teammate want to ask a problem.
Yeah, hello, can you hear me? I'm
Okay.
Yeah, I want to ask a question about the kind of solution. I see you use many kind of solutions to do the pre-experiment. I think that's a very good point. And I do think the kinds of solution influence the time of the glowing. Will you use the salt with water and it has some time? Do you have some kind of experiment about the kind of solution and the time of glowing? And what do you think about this kind of influence?
Of course, the solution of the question is determined of the salt, and we can see that the glow is determined by salt in the solution.
Yes, thank you. And well,
Okay, we have time for another question.
yeah.
Okay, and I want to ask another question that I see that you do when you're talking about the temperature that influence the gap size, and have you considered that when the pickle's temperatures keep rise, and maybe the pickle will lost water and shrink, you know, and this may create a cause of space, and it may make the gap may be bigger, you know.
Yes, of course, it influences, and it is taken into account in the evaporation function, which you can see here. Indeed, as the water evaporates, the mass of the pickle itself decreases, but like we divide the two stages of the problem, the current flow inside the pickle itself, which is unevaporated, and the flow of the current inside the gap. So yes, it is taken into account, and yes, it influences the final result.
What do you think, what is the most important could be done in a reporter solution to improve it significant? So what is the most important point for improvement?
I want to as again, if you just ask what I was looking at about the reporter's presentation, which is the most points of need to improve. Is that?
Just one, the most important.
I think if they just fix the post position, I think.
So the position of electrodes is the most important point, right?
Yes.
Thank you. And dear reporter team, what's your point of view?
Mainly would be much better if we have a uniform pickle. Usual pickles are ununiform.
Yeah, I mean, what you can do more with setup that you basically have with the real pickles, not the ideal one. So what are the most important experiments that you can do or could do to improve your solution?
Like to fix electrodes, but we have done this in our report.
Yeah, I mean, okay, I can say in another way. What's additional experiments? What is the most important additional experiment you could do to improve your solution? Just as a point of improvement.
Or just with additional experiment without a salt to show that there is no glowing, or with other salts, with other internal structure. I don't know.
Okay, I got it. Thank you.
Thank you. Leandro, can you come with your question?
Yeah, sure. I am not a specialist in cucumber emission, so I have very simple questions. The presentation is very dense, 39 slides, and I think it missed some important points. So the main question is, why do we see the emission from the ions, and how do you excite them? And why don't you see this kind of emission normally in conductivity in fluids with electrolytes? And it's for both teams.
Let's start from reporter. Yeah.
Sorry, can you just repeat your last sentence?
The question is, how do we excite the ions to emit light? Which process is involved? Because there were lots of equations and lots of considerations, but I didn't see either in the presentation or in the opposition any discussion about why in cucumbers we see emission while we do not see emission, for instance, in conduction in any salty solution. What is special about cucumbers? That's a question.
Can we answer, reporter team?
Yes.
Okay, mainly we see glowing in the gap, and it is caused by the salt. If we do not have any salt, there is no glowing, and thus we do not observe this effect. This glowing is caused by the ionization of a sodium, which is caused by the current. It's just a usual ionization effects which may be observed in this case.
Okay. Opponent team, do you have your slide?
Maybe I think the special point of the pickle is that the pickle's body may limit the currents, and in my view, the limited currents may just have make the voltage between the pole and the pickle just cross the gap. The voltage cross the gap may reach a really high voltage, and this may create the phenomenon of the glowing.
Okay, thank you.
Okay, thank you. Jerome, can we move to your question?
Yes, sure. For the opponent first, you said that the steam can evacuate some salt. Do you have an idea of a mechanism for which? How can steam could transport salt?
You say the steam points. In our point that the steam may carries out some it's mainly carries out the water, and you know, the water was getting out, and but also it takes out some salt, and in our experiment we can just smell some
but okay, you smell, but you measure something.
Yes, I smell something that is not. I can say that it's not air, and
Okay. Okay.
Okay, thank you.
For the reporter, please. I found your presentation very theoretical, and do you have a link between your theory and your experiment? For example, can you measure the temperature inside the pickle?
Like, actually, no, we can define the temperature, but we can find the current flowing through the system using the amperemeter. Yes, we indeed compare the theoretical result with experimental one. We obtain the same result.
But what about the theoretical part of about heat equation, and what about the boundary condition in your electrical setup? How can you measure these parts in your experiment?
Temperature distribution, indeed, we cannot define in the whole pickle. We can talk about the we can judge about the temperature distribution by the formation of the gap. The moment when gap formates is the moment we both compare the theoretical prediction for the moment of the gap formation and experimental one, and this judges about the temperature distribution.
Okay, thank you.
Okay, thank you. Mark, your question.
Yes, thank you. So as the author of the problem, maybe one little question. Could you explain why do we see the glow from one side once again, please?
Okay, we can see the glowing on the one side because of the geometry. If the system is symmetric, then we will observe glow from the both sides. But as the electrodes, one electrode is inserted deeper than the other one, and thus due to such an asymmetry, we observe the glowing only at one electrode.
So it could be any of the sides, depending on how deep we put the electrode in, right?
Yes, we observed this in experiment.
Can the opponent side answer this question?
Do you want to reply from the opponent?
Yeah. Just in our analyzation, we believe that the electric arc may takes most of voltage, and you know the arcs, the discharge speed was really quick, and it will be no chance for the another gap to glowing, and we believe that there will be only one gap to glow, and which gap is the random problem.